Hey, Matt.
Hey, Mike.
Hey, other person. Who are you?
Hey, other people. I am Richard.
Hey, Richard.
I'm haunting you again from last year.
He's the ghost of Christmas Advent of Code.
Would y'all like to do a podcast?
Yeah.
I would like to do a podcast.
Let's do it. Welcome to Hacking the Grepson, a podcast about programming and development, and at least in the months of December and January, because there's run over, Advent of Code. And our last couple episodes were about Advent of Code, the first 2 weeks, day 1 through 14. Today we're going to be hitting 15 on. Not sure how far we will get, but we're going to do our best. But hey, we have a special guest with us who you already heard. Richard has returned. Yay!
Yeah.
To talk about the problems that we probably didn't get to.
Yeah.
It'll be fun.
Well,
I'll be interested to hear how I was supposed to solve these things and or what the problems were in some of the cases.
I gotta...
I'm not entirely sure that I solved it the way that they were supposed to be solved, but this was the first year I got all of them.
That's awesome.
Yeah, dude, that's worth a little bit of applause because that's awesome. The one thing that I remember from last year's discussion the most was all your visuals, especially like the 3D Jenga tower. Oh, yeah. That was super awesome. But I don't remember. I don't think there was such a puzzle like that this year. So.
Sadly, this year I have only one visual.
Only
I didn't do any
it's
this
for
year.
day 24.
That one seemed like it would be fun to do with a visual.
Not probably necessary, but yeah, I have one.
Yeah.
Okay.
Well, we'll talk about it when we get to day 24.
Yeah.
Which I only did for the first time yesterday.
And yeah, I don't think I tried that one at all, but we will get there. But let's start off with day 15 because we left off
15.
Finishing with Matt rage quitting day 14 because of insufficiently good descriptions.
The requirements
of what
were
you
bad.
Yeah, the requirements were bad, and he sent them back to the requesters.
Yeah. I know that, Richard, you like to play with AI, and I know at one point in time, as you were going through this year, you were having it summarize the problem statements. Did you end up keeping
really?
that going?
I didn't know that.
Did have it summarize the problem statements for days 15 through 25. I have not read them, but they are in my notes. So we could be surprised together if you want me to read the AI summaries.
That does sound fun to me.
I mean, it is definitely been the year of AI. Might as well. So yeah. So I mean, day 15 is warehouse woes, and it has a very pretty picture for the example. But I did not even get a chance to tackle this one. So Matt or Richard, take it.
Let's hear what the AI had to say about what the problem was, and then we can talk about what we did and didn't do. I didn't finish this one, but
So I had it divide into part 1 and part 2, and I had it divide into the story and the problem.
Oh, nice.
So part 1 story.
Ooh.
Lanternfish are anxious because of a malfunctioning robot is pushing boxes around their warehouse. You arrive in your mini submarine, see the chaos, and realize that predicting the robot's path might help the lanternfish find a safe time to shut it down. And then the problem is a warehouse map and a long sequence of robot movement instructions are given. When the robot moves, it pushes boxes unless doing so would hit the wall. In that case, nothing moves. The task is to track where all the boxes end up and sum their GPS coordinates, which are based off of distances from map edges. I think it did an okay job.
yeah, that
sounds
pretty
about
accurate.
right.
I did attempt this one. Looking at my note, I didn't get the answer right, I believe. But looking at my notes, the reasoning seems to have been that I kept getting distracted while I was parsing with the inner workings of Python, like repr and stir, like the built-in functions. And I just went down some rabbit holes and didn't come back out. That was more interesting to me than solving the problem.
Oh, geez.
I got bored. I got bored after a while of doing it, and then I never really got into solving how I was going to do it. But like I said, for some reason, got bogged down in the weeds parsing, And I made a whole class family for the various warehouse objects and one for direction, but they don't actually do anything. I just parsed things into that, and I was like, yeah, I'm good. And I moved on.
You always enjoy the architecting of solving it more than the actual solving it, don't you?
That is very true in real life as well.
So what about you, Richard? What was your strategy with this one?
So for part one, I basically just had a thing that shifted the node value, the nodes being each of the individual things in the grid. And so if you went up or down or left or right, it would just replace essentially the robot with the dot and everything. And then if you ran into a boulder object, then it would recursively in that direction shift things in that direction, making sure that a wall is never hit. If it returns false, then it doesn't do any of the shifts. But then if it returns true, then it recursively goes down through them.
So you're like, okay, I'm going up, and then for each object that you hit, I guess you tell it to go up, and then kind of bounce back and see if you could move. Is that more or less
basically?
That makes sense.
Basically, I do that. In a direction, if I hit something, I then determine if that thing were shifted up, if it would hit something, if that were shifted up, if that would hit something, and so on for whatever direction.
Yeah. And is that thing stationary or not, right? Because there's walls floating around. Yeah, my classes were all like, my base thing I took my base position class and then I added some things on top of it, and I'm like, is it permeable? I.e., can the robot go through it? And is it stationary? Can it be moved? And that again was as far as I built. But I'm like, okay, I know how to build. I know how to solve it with this stuff now. And it was basically that was the plan I had. I like that recursion worked because sometimes in these problems you do recursion and your computer never stops spinning.
Well, doesn't that all have to do with how big the real input is? Because usually the example is like a 10 by 10 grid, but the real input is probably like 1,000 by 1,000 or something.
Yeah.
I didn't even look at it.
That often happens, yes.
Yeah.
Luckily, not here.
The input on this one was actually the input only goes up to line 50, and then you've got like 20 lines of directions, which go to like 1,000 characters each. So you've got, a lot of directions, but it's not a huge grid.
Yeah. So you don't accidentally have, like you're pushing a line of 500 rocks and you have to recursively check each of them to see whether they hit a wall or not.
Right. Only 50.
That's good. That seems doable. So does part 2 throw a big wrench in that, since I don't even know what it is?
Do you want to guess what they did for part 2?
All right, let's see. Well, they already did this in another problem, so it's probably not this, but did they make it so that the walls disappeared and you had to and it like wraps like asteroids?
Or Pac-Man?
No. Okay.
Yeah.
No, I don't know. I guess I'll get the AI to AI summary here. Part 2 story. Shortly after solving the first warehouse woes, news arrives that a second warehouse is also in trouble. The second location is laid out almost the same, except everything except the robot is doubled in width. And that is also basically the problem description. So using the same sequence of robot moves, now twice as wide, which can sometimes push more than one box at once. Distances for the new larger boxes are measured to the closest edge of the box. Basically, it's exactly the same, except everything's twice as wide, except for the robot.
And you have to double the size of the grid yourself?
Yes.
That's a pain.
So
I would never have guessed
the
that.
Same, Yeah, so you have the same input, except everything is twice as wide, which means your little stones are also twice as wide, which means that, but since you yourself are the same width and things can be shifted, when the things are shifted left, right, up, down, they're still only shifted by one unit, which means that you can get little chains of things being pushed. So like one rock can then push 2 rocks, can push 4 rocks, etc., kind of thing. Mm-hmm. But you still need to make sure that you don't hit a wall.
Yeah. So it seems like your algorithm should still work for this, basically. If you didn't count things as two widths or whatever, and you just actually created two nodes next to each other.
So the problem with the original implementation that I had was that it was just a single check down the line. But you need to, when things split, check both paths, and it would. So I need to basically have it do instead of just having it pure like on off false and immediately move the rock if it was true, if the previous node was true. I had to do a dry run for the whole thing, for doing the check, because the original way it would just immediately move it if the furthest one out to the leaf was true, but that doesn't work if something way down the line and then another opposing branch had a problem.
Oh, right, because if you were going up and down, you can't move one part of the rock. You'd have to move both parts of the rock at the same time.
Right.
Yeah.
Oh, yeah. Okay, I see
And
that.
so if
I'm like,
any of those
width-wise, that's not a
branches-
problem. But yeah, up and down,
Yeah,
that's
yeah.
where the issue would come in.
Yeah. So yeah, that also is the thing. I had to separate the logic between up and down and left and right.
Yeah, that seems annoying. It's like, okay,
A little
all
bit.
the things could theoretically move forward. Now, can I actually move you forward? No,
Yeah.
because there's a thing blocking over here. Yeesh.
Yeah. And I think that if I had implemented part one with a dry run in mind originally, then just part one would have worked for part two right almost off the bat, but I didn't, and so it was a little bit messier.
A common theme that we're going to see through the rest of this, the rest of the problems this year, is going to be me not doing anything that was grid based. I really do blame day 14 for this. I was like, no, I'm not going to do that.
Well, it even became a meme on the subreddit. That's like, oh boy, another 2D grid puzzle, because they're supposed. I mean, it seems like around this time of the year, there's always this many. Like this just kind of becomes like the default kind of problem where you have to think about 2 dimensions to solve it. Although, I think a lot of the time that's. I mean, this one for sure, you had to actually visualize it in 2D, but a lot of times you can probably figure it out just through an algorithm without actually. It's just easier to see what's happening in a 2D grid, but it's not necessary to solve it. But yeah, apparently there were
At least there were no. I don't think there were any 3D problems this year. At least not in part ones, because those are an immediate no for me.
and an immediate yes for Richard and pretty visuals, but not this year.
Yeah. I don't think there was anything really 3D this year, which maybe is why I was able to solve everything.
So day 16 was the reindeer maze. What was this one about?
Day 16.
So day 16 AI summary, part 1. The reindeer are competing in a maze, starting from the tile marked S and trying to reach the tile marked E with the lowest possible score. Moving forward by 1 costs 1 point, while rotating 90 degrees costs 1,000 points. The challenge is to figure out the minimum score for navigating the maze. And then, given the maze layout, open walls are marked hash, open space is dot, start is S, and end is E. Basically, a little optimization problem going through the maze.
I would. So my gut looking at this one was, well, it doesn't look fun because I'm not a huge fan of maze solving algorithms in general. But I figured for this particular type of grid, I would probably just go with a breadth first search to find the shortest way from S to E. But I never tried, so I'm curious what you did.
Yeah, all I did was essentially that I had a priority queue and then put the costs for each one in there, popped off the one for the lowest total cost so far, and iterated through.
I like that approach. My breadth first search algorithms are always ugly and messy, but my depth first search ones are great
Because they can be done recursively.
Yep.
You
I
love
always
the
spend so
recursion.
long trying to do a smart way to do breadth first search, without looking it up, because I'm sure these things have been solved a million times, but that defeats the thing I enjoy about these problems.
Yeah, I mean, isn't
priority
this
queue.
just a grab the algorithm and feed it the input kind of a kind of a
That's
puzzle.
what most people do.
I mean, is there something unique about this, like compared to previous years? It seems very similar.
It is very similar. The only thing is like the cost function is like one is very small and the other is very large, but it's still pretty simple because you could just plug the costs directly into the when you're getting all of your options for your next move.
Right.
Oh, right, because it was when you
turn.
that went up by 1,000 or something.
So it's like
Yeah.
you don't want to have to turn as much as possible, I guess.
Right.
Go straight.
So you put in you put in the cost value for each of the turns as that, and then you put in the your options are a turn or a move essentially. So.
Yeah. That's interesting. I like that. That this particular style of directions of go straight as much as possible are the way I give directions to people, like in real life. Instead of like, there's an optimized way of getting to my house from the main street, but I never send people that way. I might go down to this, like go further and then turn right twice instead of go right and then left and then right and then keep going and then turn left and then right and then left. It's like,
even when I know it's faster, a lot of times when I'm driving, I just go for the less turning route.
Yeah. So Google Maps needs an optimization for that. Just fewest turns.
Yeah.
Yeah, I mean they've already got avoid highways, so why not add fewest turns? So what was the twist in part 2 for day 16?
Wait, let me see if I can guess. Okay, it's not going to be the cheating thing that they did on the other one. You had to get back and you couldn't double back on your steps. That's my guess. I don't know.
Ooh, that'd be rough.
Luckily, part 2 was pretty straightforward. I guess I can read the AI one. After figuring out the best paths, you want to find the ideal seating locations for every tile that is along any best path. So these tiles include start and end, and any open spaces that the reindeer could traverse on a minimal score route. So basically, you're trying to find good seating for the spectators.
So they're
And
not
it
not
considers-
on the path, but in an empty seat, in an empty spot next to the path.
No, it's not that difficult.
Oh, okay.
All you have to do is find all the tiles that are in any optimal path.
Oh, okay. Oh, in any optimal path, because there can be multiple that get you the same result.
Yes.
Right.
Yes.
And then add up how many of them there are.
Pretty much.
Okay, that doesn't sound too bad. I probably would end up calculating every path anyway, because I'm like, well, there might be a shorter one. I don't know. Maybe there's some magic negative number.
Yeah. I was already doing something that was pretty close, so all I needed to do was not end when I found the first one.
Yeah.
And continue until the total cost was
higher.
no longer at the minimum.
Yeah, that seems relatively
And return
straightforward.
was- So it was pretty simple.
I may go back and do that one. That sounds sounds okay.
It's so weird. All of the years that we did actively, I have never gone back to any of them. I've only gone back to previous years, and I've done almost all of 2015. I will say by far 2015 is the easiest one. Like I actually have like 40 something stars in it.
Really? Well, maybe I'll
So-
go back and do
Nice.
2015 as a palate cleanser.
Yeah, it has definitely gotten understandably more complicated and harder. Which after 10 years of doing this, you have to think of new novel things, and you can only do so many of the same kind of thing. I guess I don't know, but
I want like day 5 through 10 level difficulty, just the whole time through. Like every day of the year, I want a problem that's in that level of difficulty, and is fun. 'Cause it's not leak code.
this was the first year I even attempted December 25th and got it. Like it was definitely not that difficult, and I was surprised
Yeah.
because you would hope that it would be a gimme,
Right, that one.
because it's on Christmas. But I'm not sure if they've all been that way because I've.
Oh yeah, almost always.
Oh, are they?
the
Okay.
December 25th are much. They're usually around day 7-ish
Okay.
difficulty.
I like
And
that.
25 looked about that. And then part 2 is usually, you need to have all the stars. So if you have 49 stars, here's your 50.
Yep.
Exactly.
Which
Yep.
I've seen one time. I never completed because I don't think I have 50 stars in any year
Yet.
yet.
Yeah.
Yep.
All right,
Soon
so
you will, I'm sure.
So 17 I actually did.
I also got the first part of day 17.
Yes, first part. That's a good point. Let's hear the AI.
The historians have activated a strange 3-bit computer that reads a program composed of small 3-bit opcodes and operands. It registers A, B, C. Its registers A, B, C can hold any integer, and the instructions manipulate these registers or produce output. You must run the program with the provided initial register values and determine the resulting output. So, part 1, you are given a specific initial state and the registers of program whose instructions you must follow. By tracking the register changes and outputs of the out instruction, you obtain a final sequence of comma-separated values. The puzzle asks that you provide the sequence. What's the problem? Program halts.
So I thought this one was, among other things, pretty straightforward. For part 1, I was like, follow the instructions, I think is the way you classify these problems. One of you guys.
Agreed.
Yeah.
I like those. My solution was I created a computer 3-bit class and literally made methods for all of the different types of operations you had to do, like combo and ADV and BXL and BST and all the various instructions. And I just executed them. A lot of fun. I enjoy that kind of thing a lot. I'm like, yay, it's just parsing and then doing.
Yeah, it was very follow the instructions.
Yeah, I agree. I did the same thing. I have one class called computer and just a run command that takes an opcode and an operand and then just does the thing and you get an answer. And I was like, yay, I can read text. I mean, it's a lot. It's a lot of text. When I call these problems follow the instructions, it really just means like, can you parse what they're asking you in this glop of text, and I think that's part of the difficulty. But then always part 2 of these kinds of are like, okay, you can read text, but do you actually know what you're doing in this problem?
This one's no different. But Richard, how did you go about solving this one for part 1?
Oh, I did essentially the same thing. I have a function that gets called getOp that will get the operation, which returns the function that actually does the operation, and then I just run through them.
That's what I usually do for these things. For some reason, I built the computer in a class.
Because it's fun.
It is fun. That's the part I like.
Yeah.
So part 2 of this, well, I'll just summarize it. I don't know what the AI has to say, but
It's not that long.
you have to, instead of producing whatever it was we were supposed to produce in the first one, which is you're just getting the registers, you actually have to output a copy of the input, basically.
It's like a quine. Isn't that what they're called? Yeah. It's like a program that outputs its source code.
Right. And then you have to figure out what you're supposed to set, I think it's register A to, in order to accomplish that. I tried to solve this problem, but I never did.
Yeah. So this one was hard.
Okay. I'm vindicated.
I'm curious. I'll say the things that didn't work that I tried, because I wrote a couple of them down. Tried my original solution. That didn't work. Literally, my initial thought was, I'll try it with my original solution, but there's no way it will ever find this answer, and I was right. So it's, sometimes it's good to be pessimistic because you get to be right. My second thought was maybe I can work backwards, like starting at like the end. How do I produce that? And then, okay, given that, how do I produce this thing? And then given that, how do I, and working backwards. And it looked like, it was kind of fun watching the output because it looked like in a movie where they're trying to like hack a door code and it like goes bloop, bloop, and like spins through. So it looked like that. And I was like, hey, that's the first time in my life I've ever actually written something that behaved that way. Still took too long. And I never figured out, I'm sure there's some pattern or something in it that you're supposed to find. And I never did.
I worked on this for a little while and I was not exactly sure what it did. And so I rewrote my specific program as like what the program, and I think probably everyone's program, except that they modified which things got scrambled, actually did was it would get the last digit and it would use that to essentially have a little offset where it would grab the actually scrambling thing for XORing the bytes, so basically moving them around. And then it would output that. So you have to work backwards. So you're on the right track. But the tricky bit here was, and this is what I think I put in our little chat earlier, was that you have to, and why it was difficult to also do by hand, is that there may be two things that early on that are possible solutions, and the lower number might not be it.
Yeah, I discovered that I started putting out all of them and putting them into like a stack of like, okay, now look at that one. You know? See how far you can get until you run into but the problem is there's no upper bound of like, well, there is an upper bound. It's I guess like the next highest number, but like you'd find one. I'm like, well, how high up do I need to go before I stop assuming I can get there?
When you're working backward, there's generally going to be either one or two that are possible last digits, because all of the digits are dependent on the most significant bit, only one of them is most dependent on the most significant bit, but all of them are to one degree or another are dependent on like the least significant bit. So after you, I may have gotten that reversed, but the idea is that you can work from one end and assume that the rest of them are not dependent on it.
All of these sticky notes in my hand here, which is like maybe a dozen.
Oh, nice.
Every single one of those was me. It was an attempt at solving this problem. I'm like just trying to keep track of what the hell was happening in it. It's like so there's all numbers. They mean if anyone were to look at these, they would have no clue. I barely know what they mean.
Like Charlie.
But I had situations where I had like 3 or 4. I had at least one situation where I think I had 3 numbers that could have theoretically given me that same digit. And that was around where I was like, I'm done. But you seem to have simplified the actual calculation of it better than I ever did.
I went through going from one end, found all the possible all the possibilities for that, started with the lowest one, moved on, and then basically it would backtrack to a previous digit if there was no possibility of moving forward. And then it just basically iterated through all those that are needed until it found one. Usually there weren't enough for each level that you would like explode in complexity. So it still ran pretty fast.
That's good. Yeah, I think if I had simplified the execution so it ran faster, because I was still just doing the full, grab the instructions and then run the instruction thing and then do the next step it tells you to do and not really anything.
Oh, well, yeah, I mean, it was still basically doing that.
Okay.
My simplified one that I put in the chat, I didn't actually use. I just used it to understand the program.
I think I probably could have figured out better bounds on the set of numbers I was looking at to generate a given number. Probably would have been smarter, like my inputs, but I never did.
Well, since the one side is not dependent on the other, I actually, when I was finding the digits, I actually did it with a subset of the full number. I didn't put in full register values when I was trying to determine each digit. So since you're working from one end, and that part that you discover is necessarily going to be part of the solution that occurs later on, you can do it without putting in the full register value.
Yeah, and I think that's I think that's the part where I needed to figure it out, because I was like, all right, I've got 22,187 is a possible value to give me a 3 in this particular spot.
Yeah.
Now, the next one has 988 million or something like that.
Yeah, you do have to be careful to keep track of the. Usually for each digit, as long as you go from one end and not the other end.
Yeah.
You can just keep track of each one that works and continue on.
Jeez. Well, at least I was on roughly the right track with it.
Yeah.
All right. What was the next one?
Now we're on to day 18, RAM run.
I see why I didn't do this one.
What do I have notes for on this?
So mine was very simple. I don't feel like coding up a shortest path routine right now, was what I wrote, and then I just never did.
Is that what this is? Yeah.
So the AI says, you find yourself inside a computer at the North Pole. with bytes falling into a two-dimensional grid and corrupting memory locations. Your goal is to move from the top left corner to the bottom right corner, avoiding the corrupted spots as new bytes continue to fall. The puzzle gives a small 7x7 example to illustrate the path changes after bytes land. And so the problem summary, you are given a list of byte coordinates that turn these locations into the grid being corrupted, in parentheses, impassable memory cells. By simulating the first 1024 bytes landing, you must figure out the shortest path in steps from the top left to the right, bottom right corner, if a path is still possible. You need to determine the minimum number of steps required under these conditions.
Right.
So, I don't know if you want to give what your approach would be, or if I should just plow into what happened.
This particular one, I say, for me anyway, I say just go for it.
The only question I have is like for something like this, for someone who does not know like graph algorithms off the top of their head and never has, like with a problem space as small as 7x7 in the example, like it almost feels like this could be worth at least initially working out on paper, just like following what would happen. To like,
yeah, you could do that with the sample, but not the actual data.
Right, but I could.
So the actual data was like 100 by 100 or something.
Right, yeah. But just like to understand like how this algorithm even works in kind of a really basic way.
Sure.
Yeah, that's what I would do.
This would actually be a pretty good one to do it with because there's like no complications or anything like that, and it's you don't not like the other one where you, like rotating 90 degrees was way more expensive. This is just pure path finding.
Mm-hmm. Yeah, this seems like you could just do probably a breadth first search because you're trying to get shortest in there. Yeah, for whatever reason, there's something about shortest. I think it's because I really disliked a particular question on my algorithms and data structures test final like 20 years ago, 30, however long ago that was. And it was like exactly how many comparisons does the way that Dijkstra's algorithm in the textbook how many comparisons would it do for this? I'm like, I don't remember the exact way they worded it. I know roughly how Dijkstra's works.
Yeah, that'd be annoying.
But this time of every year of Advent of Code, it's just trauma. It's just PTSD for you.
That's what it is for me. I'm like, oh, it's this.
They do really like their shortest paths.
Yeah.
Yeah, it was really straightforward. It was just like you said, a breadth first search. And since you didn't need to have any other considerations, then it was just going through.
I think for next year, what I should do is in the month leading up to Advent of Code, just start going through my utility classes and adding functionality and cleaning them up. Because this year, the first thing I did was throw out my graph class from last year because it had become garbage by the end. And so this year, it stayed in a relatively clean state. So I should just be able to add on to it. So I just need to set like a reminder for November 1st or something to actually look at it.
I was annoyed by like other things I had done in the past that expanded the class. Mm-hmm. And so this year, any expansions I did were in a completely different file. And then I just sort of import extensions into my grid class.
Yeah. I started subclassing.
The ones that are needed.
I started putting subclasses in new files. And it's like, okay, I need this type of grid specifically. And I still don't have a good node and edge class, which often the grid ones, that's the right way to do it, would be to go down that path. And I just don't.
Yeah, my grid class is subclassed from my graph class.
Yeah.
Yeah, so part 2. You want to guess what they made you do?
Is it a wraparound finally?
So the hint here is that they had you do 1024 bytes falling on part 1.
Ah, that's right.
Now much more.
Yeah, so I figured it's either going to be a higher number or it was going to be what's the most number of memory that could fall, or most number of bytes that could fall into the memory that you could still escape, or something like that.
I like
Congratulations, you got it. Yeah, that's exactly what they did. So you just run
what's the complicated thing, Dad?
Yeah. So that was really straightforward to solve because you just ran it a whole bunch of times with starting from where you left off, basically, and continuing until it was impossible to solve. I mean, I guess the only thing you have to worry about there is if your algorithm has like a while true in there somewhere.
Yeah.
Well, true, or the number got too big.
Yeah. Well, I mean, it's since for me it's added to a queue, and I check to see if the queue is empty or not, and so it was basically just running it a whole bunch of times.
It's like, where can I go?
Increasing the
Nowhere.
corruption.
The
Yeah.
end. Yeah.
Yep. Pretty much. Though I did have an annoying like off by one grid size error. I think that was actually in part one. Yeah, in part one I had an off by one grid size error. It's like, why is it going around all of the stuff? Because my grid was slightly too big, I think. Or maybe it was opposite. And either way, it was very weird looking.
I end up with off by one errors so much in these things.
Yep.
And I guess there's only 3,000 or so blocks that could even have fallen if I'm looking at my if I'm reading my input correctly. 3450. So yeah, that seems like it wouldn't be too bad. There's a definitive end where even if you weren't smart enough to write your code to like say, hey, I can't move anymore, therefore this won't work. You still like, okay, I got to 3450 and I can't. There's no more steps, so I guess I'm good.
Yep.
That's not too bad.
Yeah, it was considering the difficulty of day 17, it was a nice break.
Yeah, I will say I do feel like they do a pretty good job of that. Of like when there's super high difficulty ones, there might be a couple of them in a row, but then they'll give you a break for a couple of days.
Yeah.
Like I didn't do about a week's. There's like a week's where I just didn't touch them, and then there were like 3 or 4 days where I just was able to get the part ones almost immediately.
Cool.
All right.
Speaking
day
of which,
19. Yes.
yeah, day 19 I think is one of those harder ones again. At least that's what I thought of when I saw it.
Yeah. The linen layout.
layout.
What does AI tell us this one is, Richard?
You arrive at an onsen where you need to pay an admission fee, but you don't have the right currency. The staff offers free admission in exchange for helping arrange their towels, each of which has a colored stripe pattern. You must figure out how to form each requested design exactly using the unlimited quantities of the available towel patterns. So the problem description is you're given a list of available towel patterns. So they're basically little strings like R, WR, so R is red, W is white, etc. And the towel patterns have those on them. And a list of desired stripe sequences that need to be formed. Each design can be constructed by concatenating any number of towels in order as long as the stripes match exactly. You must determine how many of these requested designs can actually be formed from the available patterns.
So I did attempt this one. So my general thoughts on this coming in were like I'll just see what happens if I brute force it, see how bad it is, because that's usually like, all right, until I run it against the actual input, I never really know where it's going to bottleneck me. This one, the brute force way basically just immediately worked for the sample. On the input, I couldn't even get past the first pattern that way. So I wrote down a couple things I was like, I'll probably try this, but I haven't come back, which was possibly working from the back end first, rather than starting at the beginning. Like, which towels could I make here? Look at the end so that I could like memoize things as I went. Or possibly both, memoizing what positions in the pattern, like what the different combinations of towels could produce pattern-wise, so I could just match, like, which things could make these letters and drop through. But I never ended up coming back to this one.
I did sort of do both of those things. I think that I probably could have made my code simpler. I was expecting a part 2 that was harder than what part 2 ended up being. I split the string in every possible place, checking that the left and the right side are both possible, and if they are, then it's possible. I originally had a performance issue because I forgot to cache the impossible strings as being impossible. But after I cached both the possible and the impossible strings, it ran pretty much instantly and was okay.
Did you run from the? Oh no, you said you end up splitting the string in various places to see if it was possible.
Yeah.
So, did you recurse down each side, kind of like a, sort of like a merge sort?
So a little bit. So that was the other part of it. Let's see. That was potentially tricky. I tried the longest part of the combination first and worked backward, and only the left side. Or only the right side I recursed on. So the left side, I saw if that whole string was something that had been previously seen. But on the right side, I recursed down until the minimum possible one. And then I basically shifted my pivot to the left for each one.
That makes sense. Cool. Yeah. Yeah. Once I ran this, I was like, okay, this is a memoization problem. And I wasn't in the mood.
I could do it. I don't want to.
They should have made day 14 day 24, and then I wouldn't have been burnt out.
Then you would have gone through everything.
I'm sure of
day
it.
25.
Yeah, I was super busy in December with work, but it was definitely just day 14 that threw me.
Yeah, I think that's the first year that there's been a puzzle that's just thrown you so much where you're just like...
I was just really mad about it.
Yeah.
All right, so what was part 2?
Yeah, what is the not quite as hard part 2?
So the staff decides, and I'm reading the AI thing here, that they want to see every possible way in which the design can be arranged, rather than just knowing if it's possible or not. They still offer you the same deal. Fulfill the request, and you can enjoy the onsen.
Just pay money at this point. Come on.
No, you don't have the right currency. That's a common theme this year. We got a very anti-capitalist style.
Yeah, services bartering. Yeah.
For each design, you need to count all the distinct ways it can be constructed from the available patterns. Then you add up those counts across the requested designs. Your task is to provide the total sum of all possible arrangements for each design. But, yeah.
So that seems like you could just use your previous approach more or less for that, just with a different stop condition.
Yeah, essentially.
Yeah.
So
it's always nice when they do that.
So Richard, what were you?
If you solve it correctly.
Yeah, what were you thinking it was going to be that was harder than that?
I don't remember anymore. I was just looking at my notes.
Okay.
Yeah, I don't remember what I was thinking it might be.
That's fine. I was just curious.
Sometimes looking at these, there's an obvious way that you think they might go for part 2, and then they don't do it. But I'll try to plan. I got to I made the decision relatively early this year of trying not to worry about what part 2 was going to be and just solving part 1 and just accepting that I was going to refactor, which did help in some of the later days that I got, but then didn't help with part 2 at all.
Yeah, it can be frustrating to do a whole bunch of extra work for part 1, and then part 2 is just like, I do it 5 more times.
Yeah. Because it's not like you're reusing that code most of the time. If I'm doing something clever in my classes that I reuse, sometimes I'll pad that out and like make it more robust. But most of the time that's not the case. It's just my one-off class that I'm using for this particular problem. And like, I don't know, the dumb way, go.
So that's day 15 through 19 of the Advent of Code 2024. Thanks, Richard, for being here. And he's going to stick around for the rest of it, but that will be another episode for another day. For now, if you want to listen to more discussion of Advent of Code or other programming stuff, go to hackingthegrepson.com. And until we come back for the rest of it, we now return you to your regularly scheduled lives already in progress.